Hi everybody, this is Mrs. Ewald signing in, and today, very quickly, I'm going to go over percent composition. But the cool people, they also refer to it as percent comp. So, what it is the percent by mass of each element in a compound. What that means, really, is the part over the whole. So we're going to be looking at each element within a compound and see how often they appear within that whole compound. So the percent composition of a compound has as many percent values then as there are elements. So we figure out the percentage of, for example, in this compound, potassium dichromate, we're going to figure out the percentage of chromium, of potassium, and of oxygen. So, one thing to remember before we go any further is we need to figure out the molar mass of potassium dichromate. And this is when you go to your handy-dandy periodic table. And remember, everything that we see on the periodic table tells you the molar mass of each of those elements. So when you have 1 mole, it tells you how many grams you have of each of those elements. So if you look on the periodic table, potassium, its molar mass, so we have 2 potassium, so it would be 2 times the molar mass, and I just round to the nearest whole number, so it would be 39. And then we have 2 chromium, so it would be 2 chromium, so that would be 2 times that molar mass, which is 52. And then we have 7 oxygen, and so that would be 7 times the molar mass, which is 16. Go ahead and do all of that multiplication. So you would end up with 78, and then 104, and then 112. Then what you do is you take the sum. So it'd be 294. And what this means is when you have 1 mole of potassium dichromate, that equals 294 grams. So the unit then for the molar mass for this is 294 grams per mole. So that would be the first thing to do when calculating percent composition is first find out what is the total molar mass of that compound. Now comes the easy part. What this shows you here is the percentage of each of those 3. Well, how do we get those percentages? Well, first of all of them need to add up to 100%. So let me show you how we would calculate each of those percentages. Very easily, always think about part over whole. So if I want to know the percentage then of potassium in this overall compound, I'm going to take the mass of just potassium. So to figure out the percentage for potassium, I'm going to take 78 grams divided by 294 grams per mole, multiply that by 100. And then you should end up with 26.5%. And really, technically, each of these 3 should be gram per mole. So the unit cancels out and you end up with a percentage. So this shows you where this comes from. Next one, if we were to look at chromium, I'm just going to take the 104, so that is the amount that I have of chromium alone, divided by my total, multiply by 100, and I end up with approximately 35.4%. And then lastly with oxygen, notice oxygen here, it's not diatomic because it has partners, so don't be confused by that. You're going to end up with 112 over 294, again the total, multiply by 100, end up with approximately 38.1%. So this shows you how I got all of these here. They should all total up to 100%. If not, then you know you did something wrong. And that is basically it for percent composition. This is what you're going to use then when you get to empirical molecular formula, because you always start with a percent composition. So this is Mrs. Ewald signing out, saying happy percent composition and enjoy empirical molecular formula. That's what you should be watching next. Peace out.